Okay, now it says in parts C, D, and E, consider the case where this is an equilateral triangle. Okay, so that means this angle here, this angle is going to be pi over 3. Now this isn't alpha, guys. This is alpha minus theta. That's pi over 3. This is obviously pi over 3, and that's pi over 3 because it's an equilateral triangle. And these two distances are the same. This is R2 and this is R1, but R1 now has to equal R2. So R1 equals R2. Okay, it says, first, express Z1 in terms of Z2. Okay, so Z1 is this guy here. Z1 is equal to Z2. Now, because the lengths are the same, it's just a rotation. So we're just rotating to here. So that, when we multiply complex numbers, what happens is we multiply the moduli and we add the argument, which means it's a rotation. So it'll just rotate it to here. Now, because the modulus is the same, I don't want to multiply it by anything, or I want to multiply it by 1. So I'm going to multiply it by, I'll put in the 1 if you want. 1 to keep the size of this the same, and then times e to the I times pi over 3, because the e to the I pi over 3 complex number, or cis pi over 3, whatever way you want to call it, will rotate this to here. So if I start with Z2 and I multiply by e to the I pi over 3, it will rotate it to Z1, which is what I want. So this, well, that's the answer. Z1 is equal to Z2 times e to the I times pi over 3. Okay, that's part I. Part II. He says, hence, show that Z1 squared plus Z2 squared is equal to this. Okay, so I'm going to do a left-hand side, right-hand side kind of approach. So we're going to do the left-hand side is Z1 squared plus Z2 squared. So Z1 squared plus Z2 squared is equal to, now it says hence, so instead of Z1, I'm going to put this. I'm going to write Z2 e to the I times pi over 3 squared plus Z2 squared, which is just Z2 squared. And this is equal to Z2 squared, this squared, and this squared is going to be e to the I times 2 pi over 3, because I just multiply the powers, plus Z2 squared stays the same. I can then factorize out the Z2 squared, and I'm left with e to the I times 2 pi over 3 plus 1. That's this factorized. Okay, let's leave that like so. The right-hand side is then Z1 times Z2, right? So this should be equal to this when we're done. So Z1, Z2. Again, I'm going to use this Z2 e to the I times pi over 3 instead of Z1. And it's this times Z2. Z1 times Z2 equals, again, I've Z2 squared, but I've only e to the I times pi over 3. Okay, now this, I'm guessing, guys, this has to equal this, and I think it does actually, but we need to show that they're equal. So I can write this as, okay, let's write this as Z2 squared. We'll leave the Z2 squared because it's the same on both sides. But this e to the I times 2 pi over 3, I'm going to write it in cos plus I times sine theta form, or cis form. So it's going to be cos 2 pi over 3 plus I times sine 2 pi over 3 plus 1. The 1 is still there. Cos of 2 pi over 3. Cos of 2 pi over 3 is negative a half. Yes, I do need to know that without a calculator. And sine of 2 pi over 3 is plus sine of 2 pi over 3 is root 3 over 2, and then plus 1, which is equal to z2 squared times minus a half plus 1 is a half. Sorry guys, I forgot the I here. This is important. So minus a half plus I times this plus 1, which is minus a half plus 1 gives me the positive a half plus I times root 3 over 2. Now you're going to see that this will actually equal this, because this is z2 squared. Same thing, but cos pi over 3 plus I times sine of pi over 3, which equals cos of pi over 3 is a half, and sine of pi over 3 is the same as sine 2 pi over 3, which is root 3 over 2. Now note, this is equal to this. They're the same thing. So I'm going to say left hand side equals right hand side QED. I've shown what they've wanted me to show. Okay, obviously guys, that's not an easy question, but we're on question 12, so, and it's complex numbers, so that's what we need to expect. Okay, I'll do part D in the next video.